tutorial, we will go through the functionalities of the clinical support system that has been developed for the Aegle project. It is a browser-based application that can either be hosted on a local server or on a cloud level. It is web-based and can be accessed via a PC or any other smart device, such as a tablet. It allows for multiple users to be logged in at the same time, while the files that are being used are consistent for all users and are saved on the server that hosts the application. The analysis that takes place in this CDS are powered by the Biolytica platform, meaning that all the heavy computational intensive analysis take place at the Biolytica platform, and on the CDS only the necessary files needed for visualization and results are fetched. That allows the application to be as lightweight as possible. The CDS runs by checking at fixed intervals for any updates on the files that reside at the platform, such as new analysis results, and fetches them from the platform. The first thing that user can do in order to interact with the CDS is to click on the Assign Bed button, and a pop-up menu will appear. It contains information about the patients that are being assigned on each bed available on the ICU. These numbers are the patient ID, while the -1 stands for an empty bed. This file is generated every time the user clicks on the button, and it contains information from preview logging, so it is up to date. The user can either make some changes on this list or can simply accept it. Now the files are being fetched, and we can see also some analyses that are being presented. But for now, let's focus on the top head bar. There we can see a number of beds. Currently, we have, as we previously saw, 4 patients on our beds that are residing on bed number 1, 4, 5 and 7. On the top of the header bar, we can see that the 3 of the 4 beds are red and 1 is white. White means that there is no alarm regarding that patient is active, while red means that at least one alert is active from the patient that resides in that specific bed. There are also beds that are black, which merge with the background, indicating that the bed is empty. When we want to insert another patient in our ICU setup, we bring the pop-up window up and select the bed we want to, and type the ID over the patient that we want to insert, then click Save. As you can see, right now the files are being fetched and the CDS has been updated to accommodate this patient that we want to set on number 3. This head bar also has a browsing functionality, meaning that we can select a patient by clicking on a bed icon. On the left sidebar, we can see the Select Patient option that allows us to browse through the available beds. Only the beds that have a patient assigned to them can be selected. This functions as the bar on the top, but you can also see in which bed you are currently on. Below that, there are some information regarding the patient. This information comes from the Biolytica platform, where the data has been anonymized, so we only see some basic demographic information about the patient like gender, age, etc. Below that, there are the analysis tabs that are all available, and each of those tabs have a triangle in front of them. Its color represents the state. White color indicates that everything is in order on this specific tab, while red color means that there is an alert that came from an analysis that has been performed on that tab. Again, on that top bar, we can see that there is an alert on patient 1. Since we are currently on the patient that is on the bed 1, we can see that he has actually 3 types of alerts that refer to the nutrition, the drug administration, and the Bennett analysis respectively. The first analysis, that is also the default homepage, is the one called Nutrition Single, and it refers to the nutritional information of a single patient. Currently, we are browsing the patient 1, so the information we see refers to that patient. Here, on the top screen, we can select which type of time series we want to visualize. Apart from the results, the platform in general provides the ability to the user to go to visualize time series that can provide additional insight apart from the raw results of the analysis. This chart, in particular, represents protein and caloric information for that patient since the start of the hospitalization. The data has gone through the analytics in the Biolytica platform, thus being anonymized. Every patient has a starting date, January 1st of 1970. Right now we see the difference between the optimal nutrition intake regarding proteins and calories and the difference with the actual intake, meaning that at day 4 the patient had received 573 calories less than he was supposed to. We can change the time series that we want to present. So, instead of the difference, we can see the percentage of nutrition that have been fulfilled. Meaning on the same day, we have achieved 2/3 of the caloric need for that day. The needs are calculated dynamically, meaning that effects that make the caloric needs vary, like if the patient is under mechanical ventilation, are taken into account when we calculate those daily needs. On the bottom of the screen, we can see some features that have been used for the creation of a nutritional model that examined the chance the patient will die. This model used part of the hospitalization information and those nutritional indexes like the percentage of the calories, minerals, vitamins, etc. And this particular model has been applied on patients that have been under mechanical ventilation for over 10 days. Also on this page, we can see 2 different types of alerts. There is the alert that is on top of the chart that simply states that patient deterioration has been detected, meaning that this patient has been marked as having a higher chance to be deceased based on the nutritional model we have developed. And there is also this alert down here that states something more actionable, this pop-up window. It means that for the current day, January 10th, also known as the 10th day of hospitalization for this patient, has been detected that he has been way below the threshold for calories. In fact, he is also below the threshold for proteins, but since it is the same time of alert, it is stated only once. This type of alert, it suggests that the physician could do something directly in order to alleviate this alert. The next tab, named Nutritional Total, is an overview for the nutritional intake needs for all the patients that are currently reside in the ICU. We can see that there are 2 main charts and 2 tables that accompany those charts. The first chart, on the left, represents the nutritional intake for the current day, and the one on the right, the nutritional intake for all days since admission. As we can see right now, only the patient in beds 5 and 7 have received any type of nutrition. The chart is set to currently for calories, but we can change to include the proteins as well. Right now, we see the same type of information, but the proteins. What is the current intake, the percentage? What is the current intake as an absolute value? What is the required intake in order to reach the threshold? And the threshold can be set by the user. So, if we set the threshold for a different value, the data that is being updated, and it is also the value that is being used on the nutritional single page in order to calculate the threshold for the actionable alert. Once again, red color means that the patient is under the threshold, while blue means the patient is above the threshold. The next analysis page is the drug administration, which checks the biosignals and the drug administration data for the patient and determines whether or not the patient is subject to deterioration. A model has been created using data of 8-hour segments of biosignals and drug administration data that detects deterioration. Deterioration for this model was defined as death in the ICU. For our convenience, we can select a pair of drug, where drug has some broader sense. It also includes a solvent administered to the patient, like electrolytes, or some actual drugs, like norepinephrine, and one of the biosignals that has been recorded for the patient. This patient in particular has some measurements of glucose because he's probably diabetic, and his glucose has been measured at different time intervals. We can browse the blood signals from the start of the hospitalization till the current time. The alert on this page suggests that the patient, based on recordings of his last 8 hours, is subject to deterioration. And since we know the outcome for this specific patient, we can tell you that this patient has actually been deceased. The next tab, called Hospitalization Info, is not part of a specific analysis. Rather, it depicts information regarding the patient that is either part of the health record or that is derived from the health record data, such as Apache 2, SOFA scores, and some that are more dynamic in nature, such as mechanical ventilation total days, which can change from day to day. This page is for references purposes, for the physician to overview it, and does not provide any type of alert. The last two tabs of analysis, the Bennett and the PVI ones, refer to ventilators, and as that they are mutually exclusive, as a patient cannot be under 2 ventilators at the same time. The patient that currently resides on bed 1 is under a Bennett ventilator, and we can see that he has an alert regarding an analysis that utilizes Bennett ventilator data. The chart contains 2 time series that came from 2 different sources. The one in green is a time series that came from the Bennett ventilator, and the one in blue is a time series that came from the Aegle bedside monitor. Those time series has been collected and merged in order to be used for the analysis. Using the drop-down list of the both charts, we can select a different time series from the ones are available. With the charts being fully interactive, can be used to zoom in, zoom out, or cycle through the different parts of the signal. Below the charts are some basic statistics that have been derived during the analysis. This chart in particular, it shows events, periods of time, where the patient compliance, meaning how the patient complies with, synchronizes with the ventilator, and the higher value the better for the patient. And here, we see some events where the compliance is under threshold for a significant period of time. Using this type of data, we have created a model that predicts the next 5-minute window whether or not the patient's driving pressure will be high. High driving pressure is associated with adverse effects. There is also an actionable alert at the bottom of the screen. That has to do with the current state, meaning that currently the patient has been under a compliance event where the compliance is steadily low for a great period of time. And it is considerable actionable alert because it happens right now, and the physician can do something to alleviate the situation. In case such a period exists, it is highlighted using the light green in the top. Right now, on this patient, the period has been started from 6:20 in the morning till 9. We can now check the patient at bed number 5, that he has no type of alerts, and we can see that he's currently under a Bennett ventilator and there is no analysis that provide an alert. We can now assign a new patient on bed number 2 that we know that is under a PVI ventilator. We type the patient ID and we can go now to bed 2. We can either use the top bar or the sidebar. Right now, on the sidebar has not been updated yet. We are currently on the Bennett analysis on the patient. We know he is under PVI, so this page is empty. And when we move to the PVI menu, we can see the respective ventilator analysis. Here we can see two types of charts. The one that is interactive and has 2 time series, while the other is not interactive and provides additional information regarding the time spectrum analysis that takes place. On this page are actually 2 types of analysis. One that detects periods of times, we call them infective effort events, meaning clusters of infective efforts that are caused due to patient and ventilator desynchronization, and resulting in patient being unable to breathe. The main time series that we examine is the one in blue, called ineffective effort. The time unit of the chart is 30 seconds. 1 point of the ineffective effort signal means the patient has effective effort within a 30-second period. On this point, the patient had 5 ineffective efforts within a 30-second time window. From the literature, the ineffective efforts have been found that over 10% EE breaths during hospitalizations are associated with adverse effects. On our analysis, we have discovered that even if the amount is lower, if the ineffective efforts are in clusters on a small area, it can also be harmful. Areas such as this. Once again, there are 2 types of alerts that represent 2 different things. The first one is an actionable alert, meaning that an ineffective effort event has been detected, and as such it is highlighted once again with light green. The other type of alert is represented with the text right here. It says, patient deterioration detected, and it's the result of a predictive model that has been created based on demographic hospitalization data and the indexes that have been calculated from the ventilator time series. This model examines the likelihood of a patient to die by using the features we just mentioned. These features have been extracted by the PVI data and we can see them right now here. While this is an internal part of the analysis, they appear here for the physician to browse if deemed necessary. Regarding the charts, the physician can select which time series to check against ineffective efforts. In case that multiple IE events have been identified, the physician can cycle through them using this slider. The default position is on the most recent one, but the physician can browse through the previous ones that might provide additional information about how the patient is faring. This table right here provides results of another analysis that is linked to this chart right here. The time spectrum analysis. An analysis based on wavelet coherence that examines a pair of signals for similarities and their phase difference, meaning if the changes in one of them seem to be leading the changes on the other. In order to understand what the table depicts, we can check the time series. The distance is a metric how much the signals are alike, while the high and low frequencies delay index is a metric of how much the one signal appears to lead the other in a high and low frequencies components respectively. The range of this index is -1 to +1. A value as close to -1 indicates that the signal KF, related to lung elastance in this case, is leading the changes in the AE. In this case, the KF is considered a possible cause for the patient ventilator desynchronization that caused the rise of the AE. And we can see on the chart that at least for the beginning of the event that changes the KF signal, proceed the changes of the AE signal. As such, the causality field of the matrix registers it as a possible cause. There is no medical proof that this disruption in the KF signal causes the ineffective effort to rise, but it is an indication since the signals have been a high degree of similarity and appear to behave in the same way with a time delay. This is the information that is provided to the physician. For a selection of the biosignal, there is a characterization of their status based on the normal values threshold. On this case, the KF signal is within normal boundaries.